Hey, and welcome to this research presentation on the measures. We have a lot of different measures that we're going to go through. We have the nominal, ordinal, interval, ratio, reliability, validity. We have coding data. We have mean, median, mode, variability, range, standard deviation, normal curve, biased and unbiased, and probability. A lot of different terms, but absolutely necessary when you're writing a master degree or even a PhD. Then you really need these terms and you need to understand what they are. So this will be maybe a 30 minutes, 1 hour video, but after this you will be really prepared for writing. So let's start by defining nominal, ordinal, interval, ratio and connect them to their measurement middle. So what I'm talking about, they are these here. We are going to connect them to these three here: mean, median, and mode. Okay, so measures. Okay, on the left side I have the different measures. So let's start with nominal. And I will just give some quick information on them, and we will define them more later. But just so you know, nominal, it's things that you place in a single category, or you can label them. So if you have a survey, you will, for example, ask for gender. And gender is not a number. It's either male or female. So gender is not a number, it's a category. You will label them. And of course you can have different labels. You can label what car brand you like, and car brand is not a number. You cannot have like Tesla. Tesla is not a number, it's just Tesla, it's Tesla. Volkswagen is Volkswagen, Audi is Audi. So you need to think about category. Nominal, and think of the O here, because we're going to use the O later. Okay, and then we have ordinal. And ordinal is data that you can use on a rank. And I just want to say here that when you order something on rank, you can get first place, second place, third place, fourth place, etc. So think of, for example, if you grade some papers that you're a teacher and you grade some papers, you will have like, oh, he came first, he came number 2, he came number 3, etc. Like who scored the most, who scored the lowest. Football team, who won, who is number 1, who is number 2. And we say have nominal, we have an O here. We don't have an O here, so this is like a trick that I use. So nominal, single category labels, ordinal, rank. Okay, and then we have interval. And interval, it's something that has an interval between them. So if you think of some measure, and there's like an even interval. So for example, the temperature in Celsius or Fahrenheit, they have like interval, 1 degree here, 1, 2, like, yeah, oh, this way, 1, 2, 3, 4, 5, 6, 7, 8. So 1 degree in middle, and this is temperature in Celsius. Also, spelling test. How did you do in the spelling test? It's an interval between them. You got 10 points, 15 points, 20 points, 25 points. That's like there's an interval between them. And then we have the last one, which is ratio. And ratio, it means to like calculate something. And what is special about ratio? It has to have a zero. Has to have a zero, a true zero, not just a zero, because you have zero in temperature in Celsius also, but the temperature in Celsius is not true. It's just a zero. It's not true. So age has a true zero. You can be 0 years old. Time has a true zero. The time can be 0, 0, 0, 0. So time has a true zero. Temperature in Kelvin has a true zero. I think it's minus 273 degrees Celsius. So this is a true zero. So ratio, something you calculate that has a true zero. So interval doesn't have a true zero. So if it has a true zero, it's interval. If it has a true zero, then it's ratio. Okay, now we know these are the measurements. The measurements can be one of these: nominal, single category labels with gender, ordinal, some rank, interval, special interval between them, ratio, interval but true zero. Okay, then we are going to connect them to the center. How can we measure the center of them? The first one is mode, number that occurs most frequently. So a trick is that we have male and we have female, a gender, and we assign male 1 and we assign female 2, and then we can see which one occurs most frequently. So this is mode, and as I said, there's an O here and there's an OE mode. So the first O, that means that they are connected. So look at the O, then you will remember. Special trick. O, mode, nominal, O. So remember the O. It's easy, if you know this, it's easy for you to remember them on the test. So number that occurs most frequently, that is mode. Okay, ordinal. How can we measure the center? We measure with a median. So we select the medium score as median. So if we have 1, 2, 2, 3, as these are the results. Which are the center? Yeah, it's 2. Of course it's 2, because 2 plus 2 divided on 2 is 2. So you take down but the center ones and divide them on 2, and then you get the middle one. And if we have 1, 5, 2, then we need to sort them first. So 1, 2, 5, and we just take the center one. So the median here is 2. So always the center. So median is the center. Select the middle score as median. And the trick, ordinal does not have an O at the second letter, median does not have an O at the second letter, so you can connect them. Nominal is mode, ordinal is median. So use this trick if you're going to take a test on it. Okay, next one is interval and ratio. They use the same. They use something called the mean. Okay, and the mean is easy also. It's just a sum of all the measures. So if we measure some like temperature in Celsius, we measure 12 degrees, we measure 13 degrees, we measure 12 degrees. Then it's a sum of these. You need to plus these together and just divide them on how many they are. So the sum these divided on how many. So the formula is something like this: sum of the measurements, I think maybe it's x or something, divided on n. That is median, x. So it looks terrible, but it's really easy. Just take the sum of all the measurements and divide them on how number, and you get the mean. Mean, it's interval, and ratio, they are using mean. So let's sum up. Nominal, single category labels for gender, they use the mode. Mode is number that occurs most frequently. Ordinal, ordered along some type of continuum, for example rank, they use median, and you select the middle score as median. Interval is temperature in Celsius or spelling test, they have a special interval. And ratio, age, time, temperature in Kelvin, they have a true zero, they use mean. This is super important, you really need to know this. This will 100% certainly come on your test if you're taking a test in science. Okay, next slide. And we're going to take the full definition of nominal and the other measures, but the previous slide is the one that you really need to know. Now we're going to go in depth in nominal, ordinal, interval, and ratio. So we're starting on nominal. Nominal measures differ in quality, Okay, this means that the measurement can be placed in a single category. Example, gender will be either either male or female. Okay, what does this mean? Quality. They differ in quality. So quality means category. So as an example, we have male or female. That is two different qualities. So what car do you like? I like Audi, or I like Volkswagen. Or I like Tesla. These are three different quality. You can only take one. So they are a single category. This is important that they differ in quality. So they don't differ in number, they differ in quality. Numbers serve as tags or labels only to identify or classify an object. Okay, so if we use numbers, male will be 1, female will be number 2. So the numbers they are tags. So the tag are male or female. Levels of measurements are qualitative. Quantitative measurement, the opposite of qualitative, is measurement of data that can be put into numbers. That is qualitative. This is not the same. Quantitative, we are going to that now. They are measurements that are not numbers. So male is not a number, female is not a number, favorite car is not a number. So the levels of measurements are qualitative. And there are two characteristics of nominal measurements. Firstly, categories are mutually exclusive. And secondly, if numbers are used, they are meaningless beyond simple classification. Okay, the first one, categories are mutually exclusive. This means that you can either be male or female. You cannot be both. Secondly, so that means that is mutually exclusive. Secondly, if numbers are used, they are meaningless beyond simple classification. So if I classify this as 1 and this as 2, if I just have gender 1 and 2, I have to have some explanation that 1 means male, 2 means female. It's easier when you have gender because it's easy to understand. But if you have more genders than, for example, male and female, then you have to have like an explanation on what the classification are, because the numbers themselves doesn't say anything. If you have gender and you have a 3, what does that mean? You don't know. You have to have a classification. So nominal, that is tags, labels. Okay, next one, ordinal. Ordinal, the ranking. Ordinal measurements describe variables that can be ordered along some type of continuum, and also they can be ordered. So firstly, continuum, and secondly, they can be ordered. Because of this, they describe rankings. And as an example, first, second, third, fourth. So what type of rank did you get? Okay, interval. Interval measurements describe measurements that have an equal interval between them. So example, temperature in Celsius and words correct in spelling test. So special interval, and they do not have a true zero because ratio have a true zero. This is the next one, ratio. Ratio measurements have a true zero and equal intervals between them. So example, age, weight, time, temperature in Kelvin. They have a true zero. Okay, measurements are done. We know all them now. Nominal, ordinal, interval, ratio. Nominal measurement differ in quality. That means that the measurement can be placed in a single category. For example, gender will be either female or male. Ordinal measurements describe variables that can be ordered along some type of continuum, and they can be ordered. Because of this, they describe rankings. Interval measurements describe measurements that have an equal interval between them. For example, temperature in Celsius, number of words spelled correctly. Ratio measurements have a true zero and equal intervals between them. Example, temperatures in Kelvin, age, weight, time. Okay, nominal, ordinal, interval ratio. Next one, continuous and discrete variables. So continuous variables have an underlying continuum, where discrete variables are values that can be placed in the defined boundaries. Okay, whoa, they're like, yeah, difficult. So let's take an example. Continuous first. Okay, if I draw this number here, 3.14, this is the number for pi. This goes forever, on and on and on. And on the other side, we have discrete variables, for example 1 and 0. So they have an underlying continuum. This means that the continuous variables goes on forever, or they stop sometimes. So they have a comma something, 3.14, and discrete, they are in categories 1 or 0. And of course it can be 1, 2, 3, like for example the gender thing. So discrete, yeah, they are much easier to do for math, but continuous, yeah, they are also important. So both, and now you know the difference. Okay, we have gotten very far, and we are going to go for the next part, which is reliability and validity, and we're going to start with reliability. So what is it? It's when you reliability is when the test measures the same thing more than once and the results are the same. So if you have a test and you do it twice and the results are the same, then it's reliability. Okay, so it's actually a formula, and it's the true score divided on the true score plus the error score, and that will be a number. Okay, so it consists of observed and true score. Reliability consists of observed and true score. Okay, what is this number here? Error score. Where error score are the factors that can cause the true score and observed score to differ. They are made up of method and trait errors. So error score is method errors and trait errors. So two types of errors can happen. Okay, the first one, method error, is a differ between the true and observed score because of the testing situation. So think of the word method and think of testing. So you have a test and you do some method, and this causes some errors. So an example, you are having a test and you don't have enough paper for the students to write on. So of course this is a method error. There is something wrong with your method, or the questions you have are too complicated. The students don't understand what you're thinking of, or you have questions that contains two questions in one question, so they don't know which one they should answer. Something is wrong with the method. Next one, trait errors, is the characteristics of the person taking the test. Okay, trait, something wrong with the person. So for example, if you have a test and the person don't understand or haven't trained for the test, there's something wrong with the person, not with the test itself. The test itself is good, but there's something with the person taking the test. Okay, two error scores, method error and trait error. Method, something wrong with the method. Trait, something wrong with the characteristic of the person taking the test. Really important, these two. Okay, let's increase the reliability, and to do that the guy named Salkin suggests the following. Number one, increase the number of observations. So if we have more tests, then of course the reliability will be better. Number 2, eliminate unclear items. So if we have a test and the person taking the test don't understand the questions, then we should remove them. Number 3, standardize the test environment. So if someone is taking the test in a new computer lab and someone is taking a test in an old computer lab, maybe the person taking in the new computer lab will do better than in the old. So they should have the same test environment. Both should do in the new computer lab. Number 4, standardize instructions. Of course, if you have some tests where the instructions are easy and some tests where the instructions are difficult, the people taking easy instructions will do better. So the instructions for how to take the test should be the same. And moderate difficulty degree of tests. So if no one gets any scores, then maybe your test is too difficult. Consider external events and minimize the effect of them. This is really important. Don't do the test right before spring break, because people will think about the spring break and not the test. Maintain a consistent scoring procedure. This is also important. If you do the scoring of the tests, the scoring should be the same for all tests. You shouldn't like half into them, like think that, oh, maybe we should change the scoring system. It should be the same. Okay, these are how to increase reliability. Okay, so we are going to measure reliability. And reliability measured is called correlation coefficient and is represented by a lowercase r. The more similar the results change from one to the next, the higher the correlation and reliability. Reliability coefficients range from +1 to -1, where +1 is perfect reliability and -1 is no reliability. Okay, +1 to -1, +1 is the best, -1 is not so good. Okay, and then we have different methods, and the first one is test-retest reliability, and that examines consistency over time. We have parallel forms reliability, and that one gives different forms of the same type to the same group of participants. We have inter-rater reliability, which measures consistency from rater to rater. It can be computed by number of agreements divided by number of total periods of time rated. And we have internal consistency, which examines how undefined items are in a test. Here, the important ones are test-retest reliability, parallel forms reliability, and inter-rater reliability. And the number is also important. +1 to -1 reliability coefficients. This is most important. So when you test, there will be like they got a range maybe from, or someone got their reliability coefficient of +1 and some got 0, which is the best. Okay, let's continue. Validity. Validity is the test used for measurement is correct. So that the test used for measurement is correct. Okay. Okay, so there's 3 aspects of this, and they will help you explain how validity is defined. So validity is that the test used for measurements is correct. So there are 3 aspects. Number 1, validity refers to the results of a test. Number 2, validity occurs in degree from low to high. And number 3, validity must be interpreted within the context of which test occurs. Okay, it's a bit like, yeah, a bit difficult, but we will get there. So the test used for measurements, it has to be correct. Content validity, that indicates the extent to which a test represents the universe of items from which it is drawn. So often expert opinion is used. Here I would like to think of content validity, expert opinion. That is important. Criterion concurrent validity, if a test presents performance. Criterion predictive validity, if a test predicts performance. Construct validity, to check if a result of a test are related to an underlying set of related variables. So let's look at how to test construct validity. So we need to check other established tests. We need to show that scores on your test will differ between groups with and without certain traits. We need to analyze the task requirements of the items and determine whether these requirements are consistent with theory underlying the development of the test. Okay, next is multi-trait, multi-method matrix, and that uses different methods to measure traits. Okay, we are done with validity. It's a bit difficult and it requires a bit more study, but yeah, it is a part of research. These next parts are much easier, and this is coding data. And as I said when we started, gender can be male or female here. So 1 represent male, 2 represent female. Age is age, and score is like a score on a test. So these are called columns. So you have on the y-axis columns, and each of the data that we put in is called a row. So one test is one row, and here we have 3 rows, and we give each test an ID. Okay, so this is how we code data. And we have something in store. We have explicit and we have discrete data variables. So let's do explicit first. So I have written down here explicit data. A customer buys a product, rates a film, or gives a thumb up or down to a post. The customer is clearly showing her feel about the product. The data we received is clean and actionable. The opposite of explicit is implicit data. And implicit data, a customer views a product but does not make a purchase. A user watches a film or reads an article about something. We got a statement of intent but no clear affirmative actions. Okay, so if you think now explicit, I wrote the number 3.14, which is pi. So this is explicit, and discrete is male, female. 1 or 2, male or female. So explicit and discrete data. It's easy, but it's like difficult, but when you grasp it, it's easy. So explicit something. With numbers, discrete 1, 0. Or if you do Volkswagen, Audi, that is also discrete, because there's like tags categories. Okay, now we are going to do mean. And mean is used for interval or ratio. And the formula is, it looks scary, but it's not. X with a dash over, it just means mean. This is a sum. This special sign here is just a sum. So you take all of your measurements and sum them together. So if you have 1, 5, and 3, then sum of x equals 1 plus 5 plus 3. So it's not enough difficult, it just looks terrible. And n, that means count the number of measurements. So our n was 3, because we had 3 measurements. Okay, x with the dash over is mean. Sum of x is sum of groups of scores, and n is the size of the sample. And this will calculate the middle score. And as an example, age in years. And this is only used for interval and ratio data. Okay, the next one is median, and that is used for ordinal data. Okay, and then we have 2 different examples here. We have when numbers is odd and when numbers are even. So if we have 5, 1, 5, and 3, this is odd because there are 3 measurements, so we need to use odd. But here we just order them from small to highest, count the number of score, and select the middle one. So here's 3. This is the middle one. If you have 1, 5, 3, 3, then we are even numbers. Then we need to count them. We count them, they are even. We find the 2 middle ones. 1, 3, 3, 5. The middle ones are 3 plus 3. And we find the mean. And the mean is 3 plus 3 divided on 2. So this is 6 divided on 2. That is 3. So 3 is the middle. So if you have odd, you need to follow this procedure. If you're even, you need to follow the other one. And when do you use it? For example, with birth order. Who was born first? And you usually do it because it helps when extreme scores are included. So if someone is 90 years old, they will be excluded from the median. A mode is nominal, and remember the cool rule we created, O and O. It's the number that occurs most frequently. Example used when calculating gender. Okay, variability. Variability is degree of spread or dispersion that characterizes a group of scores. Also, it is the degree to which a set of scores differ for some measurement of central tendency. And central tendency is often the mean. Okay, so variability, we have a mean, something in the middle. We go back 2 slides. Here, mean, something in the middle for interval or ratio, some age in the middle, how many age is the middle one. Then we can see how much the spread is. So variability, the spread from the mean. Okay, range. Range is difference between highest and lowest scores in the distribution. Okay? Range, difference between highest and lowest. Standard deviation. Standard deviation S is the average amount that each of the individual scores varies from the mean of the set of the scores. And the formula is a bit messy. S square root of sum of x minus x medium in 2 divided n minus 1. But if you just think about it and you just look at this one, this is 1x. So this is just one score. And this is the average. So this is the mean of all scores. So it's something with one score and the mean of all scores. And we have the n, which is the number of scores, and we take away 1 because the 1 is here. So it's not very complicated actually. It has something to do with one score. Okay, S is standard deviation. Sum is the summation of set of scores. X is an individual score. X with dash over is a mean of all scores. N is the number of observations. Okay, normal curve. Normal curve is the shape that represents how variables are distributed. A normal curve looks like this, where the numbers are Most of the numbers are here in the middle, and you have some numbers here and some number here, and they are the ones that are here are the lowest scores, and the ones on the upper are the highest scores, but most will be in the middle. Okay, unbiased, unfairly prejudiced for or against someone or something. So this means that you have set up your mind before doing something. And we don't want to be biased in research. Unbiased, the opposite, showing no prejudice for or against something. Probability is simply how likely something is to happen. Okay, we know everything now. Let's do a small test to see if we have learned something. When you have ordinal data, for example range, then which is the best measure of central tendency? Is it range? Is it mode? Is it median? Or is it mean? Okay. Ordinal data. What is ordinal data? Well, if we look here it is. Ordinal describes the variables that it can be ordered. Ordinal, ordered. They describe ranking. Okay, so we know ordinal data is something ranking. And what do? We use the median, because we range something from small to high, and we take the median. This is really important. So, when you have ordinal data, which is the best measurement for central tendency? So it's not range, it's not mode, it's the median. Because we take something from a range and we use median. What should be used to compute the average gender of subjects? Average gender. Is it a mean, mode, median, or standard deviation? Okay, what is mean? Okay, let's think of first, what is average gender? Average gender is nominal data. Nominal data. This is important, it's nominal data. Average gender, nominal data, could be either male or female. And because of this, you get 1 or 2. So you always get 1 or 2. So mean, it will be the average. Mode is for ranking only. Median. What is median? It's the ordinal. So here we have mean, interval or ratio. But mode is for nominal data. So nominal data, we use mode. Example when calculating gender. So this is mode. Mode will be the correct one here. It's male or female. So what would be used to compute the average gender of subjects? not mean, it's mode. Mode, how many? Okay, for what data is median best suited? Okay, median. Let's think about median again. Let's go back here. Median is ordinal. It's extreme scores. So median is ordinal. They are best suited for extreme scores. Okay. Oh, sorry. For the following set of 10 scores, compute the range, the standard deviation, and the variance. Okay, let's think of the range first. First, we need to sort them from low to high. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need to sort them from low to high. So 3, 3, 3, 3, 3, 4, 5, 5, 6, 6, 7, 8, and then we have 5, 5. So the formula was 5 plus 5 divided on 2, so 10 divided on 2, and that is 5. So the range here is 5. The standard deviation I will not calculate now, it's really difficult to do without calculator, and also the variance. But the important one that you will get on your test is range, because this is easy without calculator. What measures are used to report average income of Europeans? So the average income of Europeans is, first we need to think of what number it is. Is it nominal? Is it ordinal? Is it interval? Or is it ratio? Well, it's interval or ratio, because they have equal interval between them. And we need to think, do they have a true zero? Yes, they have a true zero. It can be 0 also, so it's ratio. So ratio, it's the mean. In ratio we always use the mean. So the income will be in mean. What measure is used to report average income of Europeans? We know it's ratio, and we calculate it in mean. What are the 3 measurements of central tendency? Define each measurement. So a measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that data set. So this means that the mean, it's the mode, and the median. These 3 are the measures of central tendency. So this is all the presentation I got on this measurement, and it's really important. You should know it when you do research. Best of luck.